Okay, welcome guys once again to our AI model sessions. Today I have here Elias and Amos. I don't know, is there need for you guys to introduce yourselves? So these guys already know you, but it's good to say something. Elias, we can start with you.
Yeah, for those who are just joining us along the way for this podcast, we've been trying to cover different topics on AI. Last time it was Amos and myself. I was the interviewee answering some basic questions on artificial intelligence, and I think it's the same for artificial yesterday. Because somehow different, but almost the same.
Yeah.
So Elias here, Shamala Muhatia.
Thank you.
Yeah, Elias.
My name is Amos, and I would like to welcome you again to these sessions. If it's your first time also, let me just repeat what it is saying. This is a podcast which has been dedicated to understanding the ins and outs of AI. And we want to welcome you to today's podcast, and we hope that you're going to learn something new, something that is going to be enriching, something that is going to help you in your process of understanding what AI is. So welcome, and I hope we're going to have a very fruitful discussion. Thank you.
Thank you, Elias and Amos. Myself is Stanley Ambasu. In the village, of course, Ambasu wins the game. Today's discussion, we are going to discuss around the biasness in AI and why it's important. So, because biasness in AI will help us to rectify and determine some of the mistakes we make in these models. So, just to start with, because there's somebody somewhere who is wondering what is biasness in AI model. So maybe we can start from the far end. Amos, what do you understand with biasness in AI models?
Okay. First of all, I would like to just to have an sort of like an example to explain to our viewers what bias is. So I believe most of you have come across this term bias. Yeah, it's a very common term that we use in our day-to-day conversations. Yeah. So when you see somebody is talking and he's saying a comment that you believe that is not partial, impartial, you say that you seem biased. So bias is sort of like having sort of like an opinion or a belief that is not objective, that tends to lean towards what maybe I personally may be believing in or something like that one. So for instance, like what is very common in Kenya, we do have these problems that we do have these problems with stereotypes, and stereotype is an example of bias, where you say like people like from Kisii we like matoke. Yeah, so it might be true that everybody likes matoke in Kisii,
but that's a positive bias.
There's a positive bias.
Yes.
Yeah, so that's an example of what the common biases that we have in our life here. Yeah, so the best way you can understand is just from an example, and this is a problem now that is being observed in AI, because now these models now have picked up these biases that we usually demonstrate from our lives, and now it's when you're prompting these chatbots, you tend to see that they tend to have some bias based on races and other variables. So these biases usually they tend to be based on some other variables that we're going to discuss in this podcast.
Thank you so much, Amos. I think that explained partly what's bias, because most of the people, I agree with you, they use the word bias, but they don't really understand what bias is. Because I know in campus we used to prove statistically what bias is, but maybe let's get to hear from Elias. What's your understanding of this term bias, and what is bias in AI?
Yes. So off camera we were talking about bias, and we're trying to argue that probably a bias in AI might not be. Looking at it deeply, you start to realize maybe we need to rethink about how we look at bias in AI. Meanwhile, the way Amos has tried to explain, basically an inclination of thoughts, perspective towards one side or towards one party, instead of being objective in how we look at things. But that's also in human nature, that we tend to have preferences, and that leads to bias on specific subjects or topics or individuals or groups of people. So that is in human nature to some extent. Now, if we're looking at bias in AI, the way it's defined currently is just the AI systems perpetuating the inclination we're trying to talk about, the preference of a specific group of people over others, or the general liking of a specific group or a specific individual or traits over others. So that is how it's been looked at the moment, but we think there is more to it that we need to consider. Probably it will be part of the conversation today.
I know it's a big conversation, and to help maybe somebody understand better about what biasness is, maybe in these models, is it will depend on this conversation we are going to have today. So and why is it important? So because now we are just talking of the biasness in AI, but why is it an important topic? Why is biasness an important thing to discuss when it comes to these models or to building any other model? Why is it very important? Maybe I can start with you, Elias. Why is it important?
That might need a second thought, because human beings have always worried about making things be perfect. You see, those who are pushing for equality, whether equality of outcomes or equality of opportunities, we are wondering, when will a black person earn same amount of money like a white person? When will, in the context of Kenya, when will Akisi be a president?
But don't you think that's one? Maybe don't you think to an extent that could not be biased, because maybe they have qualifications or qualities being in that position or earning that particular amount of money?
So there are of course there are different factors that come into play. But the fact is, if we look in our context as Kenya, we vote based on tribe. So we tend to be biased towards some individuals because they come from our bloodline, and nevertheless those who have majority tend to win. So what we're saying is, even though we do that, but the desirable outcome we wish is we vote not based on our tribe. So that we are not, that I will not be biased to get in a politician just because they come from my tribe, but I'll get in a competent and a good person. So that's you can look at it from different perspectives. I know we also have gender equality thing. There are those who are saying this position should be held by women. So maybe just because they are women themselves and they are advocating for that, so they tend to be biased towards their own gender. So, but the ideal thing that we want is, you want someone who will work for you. You want someone who is good. It's the same thing that we wish these AI models to do for us. We want, when we shall be using AI models, let's say to do interviews, to get workforce in a workplace, or using AI to just do something for us. Let's say in the academic world, you want it to get the most correct information, not information that is biased based on your context. So it's basically that human effort to try and then get something that is ideal and perfect for them. So I would say that is why it's very important.
If I may respond also to that question.
Yes.
That's reference that you made, or that's example that you made in the Kenyan context, where Akisi has a very difficult time becoming a president. It's a very good example of the social bias that we have in this country.
Yes.
Because you see now, you've questioned Elias's opinion and say that it has to be based on merit or on qualifications.
Yes.
Yeah, so one thing that I have to tell you is that many cases are qualified to be president. People like Matiang'i.
No, I say, don't you think maybe it would be? But
because of qualifications.
Yeah.
So we have very many people who are qualified, but because of that element of bias.
Yeah.
Yeah, so it's very difficult for somebody outside Kisii to vote for Matiang'i to become a president. Not because they believe he's incapable, just because
He comes
from a
this-
different side. Yeah, so there's that bias. So you see, this are in now in our social world, you can see the consequence of bias. It's very harmful, and now that is our worry now. Now, if these biases are being picked from this from our lives and being taken to these AI models, so there's a high chance that these models now are going to reveal these biases onto us.
Yes.
So one example that it revolves around AI that I just come to my mind was I read about it. I think it was some years back about how AI systems in the US are encouraging racism. Yeah, so the systems themselves, they tend to be biased against certain names of persons. Yeah, so if a particular name like say Jamal comes in, that name itself, because it's just linked to a black person, yeah, and we have some other variables which have been put in place there. There's a high likelihood that person is not going to get there. The employment or move to the next stage. The opportunity or move to the next stage. So there's this harmful consequences of employing or deploying these AI models that have bias that can cause a lot of injustices to spread all across the lives of humans. So it's important for us to make sure that these models, when they are working for us, they don't transfer these weaknesses in the human conditioning into themselves and cause harm to many people all across the world.
Yeah, but also in the same line, when you're talking of, let's say, the systemic or our own human biases, we understand, let's say if you're in the Kenyan context, and then you live in the slums, I think in a year you'll be arrested, let's say, as a man, a young man, you'll be arrested several times a year.
Yeah.
You will be arrested at some point.
Yeah.
Whether it's because you've done a mistake or just because a police officer is moving around and they need to arrest you. But I doubt if such a thing is happening somewhere in Runda or Karen.
Yeah.
Because
in fact in Kenya it's much worse.
Yeah.
The richer you are, the less of a criminal you are. Even if you acquire your wealth in the wrong ways.
Yeah.
Yeah.
So such kind of biases that
Yeah.
young people in
That's true.
the informal settlement are being rounded up and being taken to the justice system.
Yeah.
You see their names, the fact that their names and identities are being recorded.
And the locations.
Location, that is, and age.
And age.
So all
It
those
plays against
factors, they play a very big role when you're trying to look at, let's say, the population. So you will end up making a conclusion that people in a certain informal settlement, 90% are criminals.
Yeah.
When in real sense, people who steal nowadays, they're stealing with their pens in offices.
Yeah.
So big criminals are not in the slums, but rather. So in trying to say all this, we are emphasizing that our systemic biases, if they are perpetuated by AI models, then we are likely to see very serious implications.
On top of that one, because there's something that Elias had mentioned in the introduction.
Yeah.
When he mentioned that we were just discussing off the camera about now why these the AI systems have become biased. So the thing is this, the fact is this, the intellect that these artificial systems acquire, they acquire from learning from humans. Yeah. So whatever.
In fact, we're the ones who train them.
We're the ones who train them. They don't magically just become aware.
Yes.
Yeah, and do all this. You know.
They basically learn from the information
that we give them. Yeah. And this is something that I think we did discuss in the previous podcast where I was interrogating.
We were talking about some of the misconceptions.
Misconceptions of
bias was one of them.
Exactly. So the models themselves, they don't go and collect this data and then just become aware and start now giving us information. No, it's us who give these models this information, which contains all these biases.
Yes.
So that's where most of the time, when it comes to most of these issues that we are arguing about, that's where most of these biases usually come from. They come from us.
Yeah.
So the models themselves are not to blame. It's now they're being formed that is to blame.
Yeah, and I agree with both of you because it's an important topic when it comes to these models, because I know when you understand the root cause of a problem, it becomes easy for you to solve. So when we understand how these biases happen, why is it important that to understand how the biases in AI models come along, and how we can rectify these biases in those models. That will help us come up with very strong systems or models that will be a bit precise. We can't say 100%, but we can say 95%. Maybe confident that it can predict something. So
on top of that, I can give a very simple example. Sorry for intruding so much.
No, it's okay.
So let's say like this AI is a dog.
Yes.
If you have a dog and you want to train this dog, and you want to train this dog to defend you against let's say some intruders, and you train this dog using an intruder who is the person who trains the dog, the person who plays like an intruder wears a black suit. So if you use that black suit as the attire for this just an intruder which you are using as a training data set, the dog will associate that suit with that act of intruding your place. So anytime this dog sees a person with a black suit, possibly to start chasing that person. So is it the dog's mistake that is chasing the person with the black suit?
No,
it's your mistake.
It is the trainer's mistake.
The trainer's mistake.
Or is it because is it a mistake of people who wear black suits?
Those are the fundamental questions.
Yes.
So how you train this dog, it has a very huge significance on how it's going to perform its actual duties when it comes to deployment. So make sure you train it with the correct data set. Use diverse clothes, and make sure whatever is supposed to symbolize an intruder is very apparent in all those training data sets.
This is very important. I don't know if we still have some minutes.
Yeah, you can.
Because when you're making this joke, is it the problem of the dog? Is it the problem of the owner of the dog, or is it the problem of the people who wear black suits? That is kind of, it forms the focal point of focus when you're looking at AI and bias. Because the quick example that we've been checking just some minutes before this is the crime rate, global crime rate. The statistics are showing, let's say, countries with black people are at the top. You look at the most peaceful countries, Scandinavian countries are at the top. So it's a total shift. You check anything else. Let's say corruption index, global corruption index. I know Kenya is doing very well there. Top 5 or top 10. Nigeria is among.
So I like what you guys are discussing. So I think we can wrap up. When we come back, I want us to understand now these types of these biases in AI. So we will talk about the types of biases in AI when we come.
Awesome.
So welcome back again. We were just talking about the importance of biasness in AI models. So I want us to dive a bit deeper into understanding some of the types of biasness in AI models. Maybe to start with Amos, maybe do you know of any types of biasness in AI models?
Oh yeah, I do know.
Maybe we can get to know some of the biasness, the types of biasness in those AI models.
Okay. So I've just remembered something that I want to let you, our audience know. So there's a bit of rain, so just bear with us with the background noise. So on top of that one,
it creates a cooling effect.
So don't sleep all the way, because the rain usually makes people feel sleepy.
Yes.
So bias is a very extensive topic.
Yes.
In statistics. It's something that we studied when we were doing our BSc and also our MSc. So it's something that is very extensive in statistics, and it's something that is also very, very important in AI systems. So bias is very widespread, and we have different types of biases.
Yes.
So in any sort of like development of models, there are very many stages that you have to pass through, from where you collect your data all the way up to where you have now your final model, which you have developed. And all these stages, from acquiring data, processing data, model selections and variable selections, all to model validation, or to that point of evaluation. All those steps there's a lot of bias which can be introduced in the entire process.
You mean each step has its own bias?
Exactly, each step has its own bias.
Yeah.
And this bias usually they tend to influence the outcome, what you really want to achieve at the end of the entire process. So even in the AI pipeline, we have the same problem, because AI models are just machine learning models. So these are purely statistical models which have been developed, and statistical models they do tend to have these biases, and we can just try to just touch on some of them. So let us just start with the entire pipeline. Let us start first of all now with the first stage of acquiring data.
Yeah, data creation or something.
Data creation or something.
Yeah.
Data creation. Data creation is where now we have the biggest problem. And this bias that I now the one which I believe for me that might be not captured very well in most of the literature is the bias which is being introduced by us humans.
Yeah.
Because these AI systems, they're being developed by data which is available in the entire internet. And you see like social media platforms, books, journals, videos, all that stuff. Everything that's in the internet, they use it as a data set to run this model. So the generation of the data itself, when somebody is posting something on Twitter or on Facebook that is biased, that becomes the first place where bias is introduced in this pipeline.
Yes.
Because now the system is going to take that information and train itself using that information which is already biased.
Yes.
And this can also happen in also academia, because you have seen also in the medical field, we have these doctors or these medical researchers who tend to do researches or studies for certain pharmaceutical companies.
Yeah.
And they tend to fabricate results to favor those companies.
Yeah. Or to favor certain drug.
A certain drug or something like that one. Yeah. So it's a very big issue in the scientific community.
Yeah.
So if these journals end up in say these models, they are going to introduce bias and misleading information. So that's where they usually will have the first point of entry, where bias is introduced. It starts from there. Now, then we move to the next stage. Now, obtaining this data, acquiring this data.
Yeah.
So it is not possible for these models to completely be trained by all the data that is available in the internet. So what has to be done, just as in any research process, we have to do what is called sampling. We have to sample the data. Yeah. So that stage of sampling the data, that's when now we start now having this let's say the research of the academic biases. So the first type of bias that is introduced there is the sampling bias. The act of sampling itself
is already creating
a bias. Yeah, because by sampling, you're not taking the information from all of us. You're taking just from few of us. So if you take information from few of us, it means someone's opinion is not considered.
It's not considered, which is already biased.
It's already biased now. So you haven't had my opinion.
Yeah.
So you're biased.
Yeah.
So sampling itself introduces bias to the pipeline. Yeah. So that's what we usually term as the sampling bias. Yeah. So down there also we can have problems now with measurement. We can have problems because now we can have problems with measurements.
Yeah.
So let's say if I'm collecting data and let's say from online sources, and let's say like I want to collect data on people's heights, and let's say I'm going to a dating site. Yeah. So where people can put in their details about maybe my height, my weight, all that. So on a dating site, nobody is going to say maybe I'm 4 foot tall.
Yeah.
Yeah, everybody's
They-
7 feet tall.
They want to be a bit perfect.
Yeah,
A bit
ideal.
perfect, so that maybe
Yeah.
if they're looking for someone who needs a perfect height or a perfect weight,
Yeah.
you can get it there.
And
Yeah.
You want to have those desirable characteristics.
Then
Yeah?
when you order something, doesn't know what you get.
when it arrives at home.
Yeah.
It's a different package.
Thank you so much,
You can proceed.
Amos. I know you will continue with that, but
Yeah,
let's
yeah.
also get to hear from Elias, because we're not touching basically where the biasness starts from. That's
Exactly.
data creation
Yeah.
and the types of biasness
Yeah.
that exist there. So, Elias,
Yeah.
maybe you could tell us some of the biasness that exist in this
Amos
data
was taking it so serious here to introduce some joke.
yeah. I know you was diving deeper.
But anyway, you look at the issue of bias, you realize it's quite complex.
Yeah.
Amos has tried to explain some different stages in AI pipeline where AI or machine learning pipeline where bias can be introduced, whether you want to talk about data creation, where you're collecting data, trying to do feature engineering, remove some variables, add others, and do transformation, scaling, normalization. All those processes you do to some extent, they introduce bias in the system. So it's good that Amos has already described through the process, but we have, I will look at it from the level of biases already in the system. You remember the best example we're talking of the camera was the camera itself. Camera, we're talking about the camera. The camera, this example was introduced by Amos. I am yet to
verify.
To
verify, but I think it's true that a camera was optimized for a light skin.
Yeah.
Light skin, not the light skin that we have here, but but the light skin.
The white, the white.
Yeah, the white in quote, because it's not white again. so
I'm here to see a white
yeah, so
person.
there is no white person. So let's call that the people in the West, the light complexion. So the camera is optimized for them. So that's why when let's say we are taking photos and you add in some filters, it doesn't make you more black. It starts to introduce in some aspects of a light skin. People see me on camera and they say, I like that complexion. When they meet me, they realize this is different. These are different package.
Yeah.
So the fact that that camera has been optimized for light skin, and then it tends to introduce bias when now we are handling data for the dark skin or for the black people. And this is Amos can explain further on it. But we have the aspect of what Amos tried to say in sampling or measurement at the introduction. You're trying to define a problem. So when you're trying to define a problem, which you will create a model for, you introduce in your perspectives already. So your own confirmation biases, you import them into the model. Your understanding of how let's say a certain business will work, your own thinking and how you want your business to run, just your own biases and your own perspectives about a specific topic or subject, you carry them into the system. So we have those that are influenced by our own systems, and individuals, let's say a data analyst or a data scientist or a machine learning engineer, they need to define a problem. And if they're not relying on domain knowledge, they're just using their own knowledge, they end up to introduce their own thoughts to it. Even if they follow the domain knowledge, the person who is advising them will already bring the expertise which is affected by biases. So it's quite a very complex endeavor that we probably need further research or redefine what bias in AI would look like.
Elias, I don't think we need to redefine it. It's either to embrace it or just find a way of getting rid of it.
I was trying to say redefine because I remember a conversation that if we're thinking of establishing a perfect AI model, we're saying it should help us to address the biases.
Yeah.
Yet we ourselves, by nature,
we are biased.
We are biased. So when we're saying we want a perfect model, do we want a perfect model that will clearly show the picture of who we are, or should it introduce a totally new picture that it will not be biased at all? And what will that mean to us? Because we shall be looking at it as if this is something strange. You see, and a good example that we're looking at, people with dreadlocks, people with tattoos. I know in some institutions they are not even allowed because when you see a person in tattoo or a person in dreadlocks, then your first thought is that person must be taking some weed, that person must be antisocial,
must be a thug,
a very serious one.
Yeah.
So those biases, probably you've been marked by a person in dreadlocks,
and now everybody with dreadlocks is a criminal.
So you end up assuming that everybody in dreadlocks is a criminal with violence, violent criminal. So if we want those AI models not to think like that, then that's what I'm trying to say. Probably redefining how we look at AI bias in AI models.
I like what Elias has said, and it basically touches on basically what we are talking about. It's the problem at the stage of data creation. Because the moment you start thinking or formulating your own things, when you want to do research or you want to do a paper, you start formulating your own things. It is that stage. You have already introduced
bias to the system.
The system. So maybe Amos, I cut you short. Maybe you were talking also about
the types of biases.
In that field or at that particular stage.
Elias interjected because I was very passionately speaking. He also started speaking very passionately here.
But you see, this is a very interesting topic because you can look at it from a technical point of view as an AI developer or a psychologist. Any level you want to look at it, you make sense out of it.
That's true. That's true. Yeah. So the other thing that you mentioned in your submission, you mentioned about now how now the human personality now brings in. That I think is being decided by human. So, but now we have that stage now where we have the experimental units. For lack of a better word, right now. Those are the people who are now producing this information, and now we have these experts who are supposed to go and collect the data, and the ones who are supposed to go and maybe clean the data, train the model and all that. All these people are just entry points for biases in this pipeline. So I was talking about now this stage of data collection, because for me I do believe like that's where we have some bit of problems.
That's the point.
That's the point of
where the problem emanates from.
Exactly.
When you have garbage in,
then it's going to garbage out. Ego. So you see, we're talking about data collection. We're talking about the sampling bias. That's by nature. We can control it by taking or resorting to better sampling techniques. So in statistics, we do have a number of sampling techniques, and part of our studies was to find out, like when you're studying bias in class, we're trying to find out amongst all these sampling techniques, which one has the least bias.
Exactly.
So, and a simple random sampling is one of the sampling techniques that has the least bias. And it's very scientific because it allows you to select your sampling units randomly.
So everyone has a chance to be selected.
Everybody has a chance to be selected to be inside the sample, and there's no particular pattern to selecting your sampling units. It's out of randomness, and that's how nature is. Nature is random. So through that randomness, you can try to minimize, but not get rid, but minimize the bias during the sampling stage. Now, the problem also arises there is that how do you do the measurements? Because now we have the measurement bias. How do you use the devices? Because the devices can be, as mentioned here, we can have people who are not who are not very good experts in
Yeah.
that particular area
Yeah.
of data collection.
Mhm.
So maybe if I'm supposed to go and collect data on, say, like someone's weight, yeah. So we have like the metric system and the empirical system.
Mhm.
So which method is the most accurate one? Which one should I use?
Mhm.
So you can record the wrong figures
Yeah.
at the point of data collection.
Yeah.
So there you start introducing some measurement bias.
Bias, yeah.
And you see, once they enter into the system, they're going to influence how the system behaves.
Yes.
And then we also have the place where you're doing sampling, because
Yeah.
let's say you want to sample the population of of Kenya. There are more than 44 tribes.
Yeah.
And then you do your research in some central region county, or even in Nairobi. And in Nairobi, even though it's cosmopolitan,
Yeah.
it still has some sections where a certain tribe
Yeah,
lives
it's
here.
Yeah, it's dominant compared to other tribes.
So if I go to Isli, for instance, and I sample, let's say, people wear what's the name of these
A hijab.
hijab?
Yeah.
High chances are it will be overrepresented.
Yeah.
And then you do the same thing in Madare,
Yeah.
or any other Roysambu.
Yeah.
You realize the population is different. People are having, ladies are having mini skirts or booty shorts.
Different culture.
Yeah, so now that
Way of life.
Tank
that
tops.
brings a problem of where even sampling.
Yeah.
So it introduces other issues that you had not thought of.
Yeah.
And if you're not careful, that will be perpetuated in the entire system.
Yeah.
Well,
So at that point now we have those problems that if you address those problems there in the data collection stage, it is going now to reduce the amount of bias that you can have as you move forward.
Yeah.
Yeah. So when you move forward now, you have your data now. So there's also a problem now. We have these individuals who are supposed to go to look at this data and now maybe prepare it.
Yeah, maybe manage the data, label, code, and
label
do
it,
that.
code
So,
it,
so I think we are going to talk about those
Yeah.
biasness now when it comes to data management and manipulation.
Yeah.
Which type of biases come in handy?
Yeah.
Because we have already talked about the biases of sampling, the biases of measurement,
Yeah.
when you are collecting the data. So we
Yeah.
want to dive now into the biases of data management in that particular section of data collection and data creation. So when we come back, we'll be talking about that.
Okay.
So welcome back again to our conversation in our podcast today. So we were just talking about the types of biasness in data creation when we are doing data creation, and we were to talk about now the biasness when it comes to data management, or where you are cleaning the data and preparing it for analysis of the next stage. So maybe let's start with Elias. Maybe you can tell us some of the biasness that exists when we are doing this data manipulation and data management at that particular stage. Are there any biases that occur?
Yeah, there is quite a lot. We've already talked about our own confirmation biases that we try to introduce in the data. We have an aspect of proxies. You say, let's take an example of you don't want to capture the element of race in your data, in your final data, because definitely it will be biased to some races or even gender.
Yeah.
And then you say, let me eliminate these two variables or this variable because you're trying to be good to the society. But in the end, you introduce what you call proxy biases. Proxy biases is where some of the important variables have been eliminated, but other factors come into play. Like you don't need to tell me where. If I take an example of a tribe in Kenya, if you've collected data in Murang'a, you don't need to tell me the tribe.
Yeah.
I'll just look at the data myself.
The assumption is
and
is
I know the
tribe.
specific tribe.
Even the best example was that tunnel we have at Pangani.
Yeah.
So
for Nairobians, Nairobians understand that tunnel because if you're going to the left,
Yeah.
you're going to the hustlers.
If you're
Yeah,
going
that's
to-
hustler.
To the right, you proceed to the paradise,
This
to
is
Westlands, to Lavington, and all those.
Yeah.
So I can tell,
By
not
the-
necessarily
by-
being
by the
told.
road which you have used.
Yeah, by the road which you've used, the coordinates which you've taken, then
Yeah.
I can simply tell, man, this looks like
A rich person.
a rich person.
Yeah.
Or if you're looking at the gender, we were talking about if you do the segmentation of the population through your unsupervised learning, you are able to pull data that or insights that will tell you this looks like it's a female gender that is buying a lot. So you introduce some biases, proxy biases that you had not intended to, but they just come into data. I don't know if Amos, you can talk about others. We have design bias and others.
You can go on.
Yeah. So the one that I usually see it happening in at this stage of let's say like also it's also in data collection and also data management. Is this the labeling bias? So how you label your data sets. So we do have there's things like this. Let's say like let's talk about income. So income brackets. So income can be collected as a continuous variable. When you're collecting it, and I know this is very, very esoteric now in statistics. Yeah, but when you're collecting income, you can collect it as a continuous variable. So we have a country like Kenya. You just ask somebody how much. Okay, it's very hard for somebody to disclose how much they earn exactly. But they can give you figures. So if you have the continuous data, it's going to be a bit accurate. If they're honest, it's going to be a bit accurate. But if, as a data analyst, when I have this data, I say, okay, this income variable, I don't want to work with it as a continuous variable. I want to work with it as continuous, as a categorical. So I want to have social economical status categories. So I say anybody who is earning income from, let's say,
0 to 20,000.
Because of bias, I can say like 100,000.
Okay.
These are poor people.
And that's what is happening with GDP, I think.
Yeah, that's what
GDP is giving very false.
But you see, GDP is more of like an average. And average is usually not a good representation of the population. Yeah. So that's a different type of also biases that we usually have. So once I start doing this classification of this income socio-economic status levels, I might be biased as an individual. So I'm introducing some bit of labeling bias in this data. So if you analyze it, it starts classifying people wrongly. Like an individual who is an individual in Kenya who is earning 100,000 a month. Okay, it's 100,000 shillings. You
have to be very.
We have more
very
in India, in the United States.
They'll be shocked. Are you talking about dollars?
100,000 every month. Dollars.
And they are being categorized as poor.
And it's just not just shillings, Kenyan shillings. That individual is not cannot classify as a general population as a poor person. He's not rich, but it's not. So it's a person who can take care of himself or something like that. So that problem is introduced by now. This individual who now is trying to label this data, and then you end up bringing some very big biases into the data, which is not going to present it.
That was a good example when you're looking at continuous data, but we have also in the image recognition, the advanced AI models. Image recognition, you have to label your images really, really well. So there are those who will label a paint and a picture as this, using the same label, yet in reality it's different. Or you look at a cat and a dog, although that's quite clear, but the cat family, there is a high likelihood that if you don't label them appropriately, let's say a wild cat and a domestic cat, so if you're not careful with the labeling, you introduce the labeling bias, which can affect the entire the entire AI model.
Okay. Yeah. If I understand you guys well, is like labeling bias is playing a very key role when it comes to data management.
Yeah.
And also, you can also talk about the annotation bias or annotator bias. You see, like there are those questionnaires or rather forms where you have to annotate, especially when you are dealing maybe with clinical trials. You have to annotate certain variables to a certain question before you analyze them. So the way maybe Amos will annotate the variable, maybe somebody has done biopsy, for example. Then you want to annotate that particular variable. You give it a different name. The same variable on the same form, I'm also annotating it and I'm giving it a different variable. So you see, it's bringing in bias for somebody who don't understand. They might think these are two different variables. So the issue of also annotation at that stage becomes also key. So, and I know there are also biases going forward when we are now doing the data analysis and the maybe validation. Maybe could you talk about some of the biases that can exist when we are now doing data analysis at that stage?
So we're doing data analysis. We do have a bit of bias. So there's that bias that Elias had mentioned, which is sort of like designer-based bias. So like the person who is sitting down and deciding on which approach to take. So one thing that you'll come to learn as a data analyst or a data scientist is that when it comes to now analyzing data, we do have different techniques that you can apply to analyze a particular data. And we do also after selecting a technique. Let's talk about this. Elias has told me that I should classify them as traditional machine learning techniques.
Traditional learning, machine learning.
Because they tend to behave differently when you compare them to ANNs. So when they're using these traditional techniques, these ones, I know they're not very powerful compared to the neural networks. But you see, if I'm supposed to develop let's say like a solution, a model which is going to solve let's say like credit worthiness for a microfinance, I don't have to go for an ANN. I can just use a logistic regression because we just want the outcome has to be categorical with only two categories. Binary. Or we can even use a decision tree. That one can work. So when I'm doing that, I might have those options, like they say decision tree, logistic regression, random forest, all that. So my choice of this model, of whichever technique that I'm going to apply, is very, very powerful. Because one thing that that is very a good practice for a data analyst is that before you settle for a particular model, make sure you have analyzed the sensitivities and specificities of those models, and also the accuracy,
the assumptions,
and also accuracy before even the assumptions, and also the accuracy. So because you do the training and then do the testing. So when you're looking at those performances, the performances of those models, that's when you can classify and say, okay, I think this model has the best performance for this data set. Let's use this one. So it's not like you don't come up with a preconceived idea and say that I want to stick with this model and that's it. So by doing that, by just designing or taking the wrong approach, you already introduce bias to the system because the model you have taken is not so powerful. Also, in the back end, those engineers that develop that set up this the building blocks, of these models, the ones who design using the software part, the way they design, the mechanism they use to design these models also is a very huge determinant. If they don't do proper formulation or proper structuring or engineering of those models, those biases that they introduce there, they're going to also come to.
I think that's what they call algorithm bias. Because algorithm bias is basically I've created a function, and that function is now, when I'm inputting data into my model, it's based on that mathematical function. So if that mathematical function already had gaps in it,
Yeah.
then it doesn't matter whether I'm biased as a human, as a person or
Yeah.
not, or that
Yeah.
my data is biased or it's very perfect. There is already a system bias or an algorithm bias that you as a human being you cannot see.
Yeah.
You only
Yeah.
wait for the output.
Yeah, because now
Yeah.
in the concept like logistic regression can be clear theoretically. Like
Yeah.
you have the sigmoid function. It's clear how we're
Yeah.
supposed to move from one point to the other.
Yeah.
But now transferring this concept to the software part of it
Yeah.
can be problematic. So if you don't capture the correct theoretical aspects of these models, you can end up introducing bias
Yeah.
inside there. So besides, on top of that one, part of this the bias is being introduced at the analysis stage is now sorry, it's a bit of noise. Yeah, it's now the well, let's say like when you're doing the analysis, now you have let's say you're sorting for the best model. You have the model there.
Yeah.
Now, how do you do the what I was mentioning, the feature engineering? How do you select your samples? Because you have several selection methods, backward selection, forward selection, and also have you done enough research on the variables that affect the outcome variables, these independent variables? Because if you don't know the correlation between these variables, there is no way you can figure out what fit the best model here.
Yeah.
So how you select your variables is very, very important, and that introduces biases like the confounding variable bias.
Yeah.
Confounding variables are those variables that they do influence both the dependent and independent variables, and they have not been
They have
captured.
not been captured.
Yeah, you have left them out.
Yeah.
You have omitted them. Yeah. And I was giving it.
But they are very important.
They're very important.
They are equally
They're very, very, very important.
If you meet them, the fact that you've not considered them, you can't even tell the effect, the absence of the effect of their absence.
Yeah.
But if you include them, you realize there will be more information that you're gaining from
Yeah.
from the data.
Yeah. That's true. That's true.
Yeah. So will that be now an omission bias or is confounding bias?
It's an omission bias, because the omission now can be intentional or non-intentional. You see.
Yeah.
So if you haven't known about that confounding variable, you never intended for that thing to occur.
Yeah.
So confounding variable in itself is an confounding variable bias. Is in itself is an omission bias.
It's an omission.
Yeah.
Yeah. Thank you for that. I think now we can now talk about at the validation stage. There are also biases that exist at the validation stage, because we have been talking through data creation stage, now data analysis stage, but now the validation stage where you are maybe validating your model. Are there biases that exist at that particular point? Maybe to start with you, Elias.
Yeah, definitely. At the validation phase is where you want to see the performance of your model.
Yes.
So if it's reinforcing your own perception, then that is definitely a confirmation bias. So if you have a certain feeling about, let's say, the black race, and then the model has actually shown the black race is this, and then you're like, wow, even the model has proved. the model has proved that all the black people are thieves or they're stupid. So, and these are things that actually exist because for us we take it lightly because we're in a majority of black people, but now those who are they are black who are considered minority in the continent, they tend to suffer so much. Let's say this justice system,
the consequences
justice system doesn't favor them. The health system doesn't favor them. So there's confirmation bias that the model has actually shown that black people with dreadlocks are actually criminals, and this you already had that assumption.
Or the model has shown that black people or people with color, let me say for that matter, have low IQ, so we can't give them jobs like engineering or
and you see, this is something we've been looking at in detail. I think we shall be doing so much research in that. We highlighted a little bit when you're studying this conversation. You look at the IQ data set that is on the internet. I don't know how it's collected, but generally it doesn't favor the the black population. It favors so much the other race. If you look at, let's say, we talked about criminal index globally. You look at even the corruption index. Now you look at on the other side, the positive side. You want to look at the most peaceful countries.
Yes.
It is inverted now. So all these things, we have already, as a society, created that bias, and then the model will definitely give us those results. And then because we want to justify that actually it's true, now we
conform to that.
We conform to that and proceed with it.
That's
do you think there is that's a very good example that can use. Though we are not trying to be biased on the race, but we are trying to just
it's just the reality.
On what
We
is
are very
happening on
peaceful
the
people,
ground.
by the way.
So Amos, do you think there are also any other validation bias that exists at that stage?
At the stage where now you're testing, training and testing your model. I think there is a lot of bias that can be introduced there, and I think all these biases they're sort of like just interconnected. They're totally interconnected. And there is, when Nicholas was speaking, I just remembered we have a problem when it comes now to even the type of data we usually collect. Because these models that like the AI models that are being developed, the AI models that are being used today, they're being trained on huge amounts of data sets. And one thing that you have to see, if you go online to this website, is called Statista. Statista. And look at it. Go online. Just go and look at that website. Google, let's say like number of let's say like Facebook users
or Instagram
by country, number of Instagram users by country, number of TikTok users by country.
On Instagram, India is leading. On TikTok, the United States is leading, but they are planning to ban it. So I don't know how that will be.
That will change even the training of the models.
It will be massive.
So let me cut you short, Amos. When we come back, you will explain the bias, that test dataset bias that you are just explaining. When we come back, and then we will talk about maybe the mitigation measures and recommendations on how we can tackle this
very
bias.
important.
Very important.
Okay, thank you.
So welcome back again to our conversation. So we were just talking about the validation bias or biases that exist in these models when we are doing validation. And Amos, you are talking something to do with the test data set bias. Maybe can you explain further?
So it's not sort of like test data set bias, but just the bias that comes in with the type of data sets that now we use now in the training and testing of these models. So as I mentioned that when you look at the distribution of the demographics of how the users of these social media platforms across the globe, you just start noticing some things, some patterns. When you're looking at let's say like a country like platform like say like TikTok, US is leading. It has the most users. So according to Statista, it's around 148 million.
But in the United States.
In the US alone. Though I heard from the CEO, TikTok CEO, he was mentioning that they have 170.
I think that was as of January this year. 2024. So
they have increased.
Maybe they have increased around 20 million things.
Exactly. So they're around 178 million. Users. So and if you look at the list, the top, let's say like the top 15, I don't think you'll find a black country there.
African country.
Not Africa, just African, but a country where we have the black race.
You see our black races all over Jamaica.
We have Jamaica, we have the Caribbean islands. We have black people there. Even the Aboriginals in Australia.
We have black Indians.
We have more.
True.
But the majority of users, on average, are white, and it's by not they can be white or just having some shades of white.
Let's say light complexion.
Light complexion, and it's a huge margin compared to the individuals with the black complexion.
People of color.
I don't know. I've never understood that term. People of color. Do we have colorless people in the world? I've never understood that term.
They say people of color.
They say it's the best way to inclusivity of black people.
People
Yeah.
of color.
People of
So
color.
if you're not a person of color, what are you? A person of colorless.
You are not you don't have color. You don't
So
have
I think it's used as a polite way to refer to black people because
Yes.
black is already stereotyped. So they tend to assume
Black.
people of color will sound better.
Yes. Black is a color,
For me-
more
for me-
color
but
than white.
maybe-
For me, if you say people, if you call me a person of color, I think that's very racist. Just call me black.
So,
I'm black.
No, you see, we are in Africa and
Yeah.
perhaps our context.
You have gotten used to
Yeah.
people
Yeah.
saying black.
Yeah.
But
Now when
countries,
you're in the States or somewhere else, probably the feeling is different.
yes.
Yeah.
I don't know, because the time you're saying the people,
Yeah.
already you put it into a cocoon.
Yes, a person of color. Or
Yes.
they say a person of
So
color.
maybe our audience in the United States who are people of color or black people, you can give us your comment which one is preferable from that side.
Yes.
Yeah.
Do you accept people of color or
I have also seen
African American.
Yeah.
I don't like those labels.
I've also seen we have a huge audience from India. You can also let us know if you are a black Indian or a black people of color of India.
yeah, so putting aside people of color,
Yeah, you can proceed.
yes, you can proceed because
Yeah, that's-
this discussion of people of color might not
Yeah,
end
it's-
now.
yeah, it's
so
a digression.
maybe you can proceed.
Yeah, so I was saying that if you look at those statistics, you realize that the black race or the people with black complexion, they are quite overshadowed by the people with the lighter complexion. So you see, already now we have that problem in the sampling stage. We have overrepresentation of a particular group of people.
Yeah.
So that's a problem that we cannot control when it comes now to these AI models. And this is something that Google DeepMind tried to do with Gemini.
It was a massive failure.
It was a massive failure. To try to bring inclusivity,
Yeah.
it's very difficult to do that because now you overcorrect your mistakes, and now it becomes very wrong, misleading, and problematic.
I can imagine what it will do to gender identities.
That one I can't even imagine.
The fact that the people who call themselves they don't belong to the binary. They have multiple identities.
You have to refer to them as they. So
So there is referring to they and the names they identify themselves with.
Yeah.
It's going to be a big problem because I will simply take whatever we're feeding it, and that will create some massive biases because they're not the majority anyway.
But because we want to bring inclusivity, we end up doing so much for a small group, disturbing the statistical element of
the entire system.
And sometimes I think one thing that we need to embrace also as a scientific community is that we need to also be aware of the actual things on the ground. I think like an example like in Kenya here, Kikuyus are the largest ethnic community in this country. That's a fact.
Based on census 2019.
So if you go to ChatGPT and you ask it, kindly write for me a story about a Kenyan man who has been selling vegetables in Nairobi and make it funny.
Definitely will.
So if you start saying about Kamau, don't say, oh, this thing is not inclusive. It's not about inclusivity alone. It's the fact that they are the majority. So there's that element of them being majority. Then they show up more often. It's the same thing about, let's say, things like height. So if you go to a country and if you want to go to a country and you just want to know what is the average height of those people, of the population, if they give you a figure, so that's what you're going to expect to see in most cases.
Yes.
So it doesn't mean that you can't meet a person who is short or even taller. You'll meet those ones.
Outliers.
But those are outliers. Or they're just small clusters on both edges, in the extremes. So That issue there
Mhm.
is something that is very hard to correct.
Yeah.
So in that step of validating these models, most of these most of the sometimes they call themselves modelers, or this is also what developing these
I'm a
models.
modeler.
Yeah, when designing these models,
Yeah.
you try to correct such errors.
Mhm.
Or such things, and then you end up introducing a lot of bias.
It's not necessarily
Yeah.
an error, it's just the way the society is.
Yeah.
Yeah.
So if you leave the model to show the actual picture, the snapshot, it's okay.
Mhm.
But because you want it to be inclusive,
You're trying to influence the
influence
model
the outcome,
to give you the outcome that
it's biased.
maybe
Yeah.
expect.
That one becomes a bias.
Yeah.
So that human intervention at that stage
Mm.
brings bias.
Oh, that's nice to hear.
And in fact, when you're talking about sampling bias, we had this process we do trying to balance
Mhm.
during model development.
Yeah.
What is
Weighting.
it? Yeah, weighting.
Oh.
Yeah. Mhm.
So that, let's say, you have equal representation.
Yeah.
Even though it helps, but this is the point where you're saying it introduces other problems that you had not foreseen.
Actually, but in the AI context, weighting is one of the most important.
Yeah.
Mhm.
That's the most. In fact, whoever owns the weights of a model
Mhm.
owns the entire model.
Uh-huh.
Yeah, so the weights they're quite important.
Mhm.
But now, adjusting those weights.
Mhm.
Sometimes we over adjust the weights,
Yeah.
and then we introduce those
Yeah.
biases.
Yeah.
Yeah. Mhm.
Oh, that's nice to hear. I think that's now, although we have not exhausted
Yeah,
this
it's
bias.
The way you say it's complex and it's quite
complex
wide.
and it's wide,
Yeah.
and we might have to come back to it again to review it and have more information for our audience, just to make them understand what is biasness in AI models. So I want us to dive into maybe some of the mitigation measures, recommendations, your recommendations on this biasness, what can be done. Maybe to start with you, Elias, what are some of the mitigation measures or the recommendations that maybe you can pose to this biasness in AI models?
Yeah, that's a nice thing to look at. First of all, we've been trying to assess this deeply, and we understand it's quite a complex thing to pursue. Trying to get AI models or systems that are not biased.
Yeah.
Yet we ourselves are biased. So
by nature.
by nature we are biased. So if we're saying that we want our models to be unbiased,
Perfect.
perfect and biased, because perfect can be looks at
Horrible.
different.
Yeah.
It can be horrible from
Yeah.
the human understanding.
Yeah, it can be perfect from my understanding, but it's biased.
Yeah, and it can be perfect from the human. It can be perfect from if we look at it perfect from the human understanding, then we are looking at it that it will not be biased.
Mm-hmm.
But in that situation, and I've already mentioned about this, where we're looking at a model that is completely perfect, that is not biased about it, it's so nice. In fact, we'll call it's nice. It can't label a certain community as thieves. It can't label a certain race as intelligent and others are not intelligent. So that's what a perfect model will be. But can we attain it? So that's another conversation. Based on everything that we've talked about, the measurement, the sampling, and all those, those are where the mitigation can come from. We're talking of if you want to label your variables, then it won't hurt to include some domain knowledge, domain expert and deep research into what does this variable communicate. What are other factors that can affect my variable? We're talking of confounding factors. If we're including all this, then we're starting to address a little bit, or maybe to a large extent, the confirmation, or rather the confounding bias that we have, measurement bias, labeling. Now, confirmation bias, it's educating yourself. You don't need to wait for someone to come and tell you that, man, black people have been discriminated for quite some time. So if you have that bias that you hate a certain race, that's actually a problem. And if it's your problem and then you belong to AI developers, it's even a double problem. So you need to educate yourself, man, because you're creating more problems for humanity, out of your own biases. So I would say, looking at, there's a lot, but I'll look at making sure that we are doing our research properly. All the stakeholders are being involved. You see, for instance, when you're developing a model, you need data analysts, you need people in that specific domain. Let's say we're talking about healthcare. Not all data analysts understand the concept of healthcare.
Yeah.
You will need machine
experts in those areas.
experts in that specific area you're researching. You need AI engineers, or rather machine learning engineers, so that when you're doing your sampling and even the system itself, we've talked about algorithm bias. It should be not necessarily perfect, but we should be aware that it has some biases in the background that we are not aware of. So, in a nutshell, that's how I look at it.
Yeah.
Okay. So, do you have any other mitigation measures you think can be put in place, Amos, to curb these biasness? I know we can't have it reduced to 100%, but we can reduce it mitigate it to a certain level.
Yeah, and that's something that we need to entertain. We need to entertain the fact that we cannot make them bias free.
Yeah.
Yes.
Yeah, it's very difficult. Yeah. So if we embrace that these models are always going to be biased, that can reduce the weight of our chests, because we feel sometimes like we are scared, sometimes because we're going to receive some bias from these systems. Yeah. So I think we do have some mitigation measures that we can adopt to try and reduce this problem. Because at the end of the day, we want these AI systems to be our like sort of assistants. The ones and it's supposed to be
to work for us,
and
produce the best results.
Exactly.
Maybe predict.
Exactly. So I think one thing that I think needs to be done to help us reduce this is, first of all, let us rank these biases in terms of their severity of harmfulness, and then from there we start reducing those harms based on how heavy they are. So let's say if selection bias is one of the biggest problem, sample selection, or sampling unit selection, we start there. We fix that one first as we go down, because there are other biases that we can just let them to stay there. Also on top of that one, we need to appreciate the fact that if we correct them, if we make these models to be very perfect, it will be, for me, I think this is my opinion, I think it's going to be very irritating. Sometimes we want that human touch. Yes. Let's say, imagine if you're married to a spouse who was very perfect. Imagine how horrible it would be.
How boring life would be.
To live in that place. It is going to be very horrible. So sometimes perfection is not always the best solution. Let's just make sure that these models, they do portray, or they do give us the best parts of humans. But let us not make them very perfect. To be very, very dangerous.
And not also influence them to give us what we want.
Let them be free to give us what is actually correct or universal. That is good.
So
I haven't finished, Buana.
Okay. You have 1 minute.
So my suggestion might be that if there is a need to have the perfect models, let us just do it. Let us just do it this way. Let us have a sort of like we categorize our models.
You've said we can't have perfect. So
no, I'm just saying if you believe that you need that perfect model, let us just do this. Let us just sort of like categorize our models. When you're prompting them, let us have a path that gives us perfect answers and a path that gives us what we believe is just a general knowledge answer. Like the general AI. We don't want the ASI first of all. You can have the path to the ASI and the path to AGI. So because for me, like, I know ASI profession can be very beneficial to humans. Let's say like in things like pursuit for cancer research, cure for cancer, we want perfection there. But also when it comes to other things, common things, we don't want perfection. We want some to be relaxed. We want answers which are relaxed. Something like that one. Yeah.
Oh.
Yeah, and I don't know, when we reach to the level of artificial super intelligence, I don't know if the model will be able to develop itself that it doesn't need to rely on our biases anymore.
So the funny thing about the development of AI is that we tend to push these definitions because if you go back, like let's say like not far, 5 years, and ask somebody, to you, if you design an artificial intelligence here, what will be a definition? What will show you that thing is intelligent? You say, oh, if it's going to write a story by itself, I think that's intelligence. that for me, I think that becomes AGI, artificial intelligence, because that's what people do. But we are there.
Yeah.
But now we have changed the definition. We said, yes, it's doing that. It's writing a story. But there's something else that is still missing. That's still missing. So we tend to push this boundary until I think one day we'll be able to be okay with what we get.
No, human beings have not been okay with what they have. We're never satisfied. Those who are rich, they're always looking for more.
We're always looking for more. So by the time we are able to like agree on what AGI is and what ASI is, I think that's when we will be having very powerful models that can bring that consensus even amongst us.
And I like what you are saying. There's this bias that exists when you are doing data analysis, because areas I know you have worked with in vivo and Atlas softwares, and I don't know if because I'm not very good when it comes to analyzing qualitative. And how can we solve this problem of qualitative? Because sometimes you'll find somebody has given a statement, but because of your biasness, when you're doing the analysis of qualitative, you tend to put the statements together, but this person meant something different. So how can that be resolved in this case, maybe so that we also reduce biasness in that area, because it's an area I tend to think has a lot of biasness.
Yes, so I don't know if I still have some minutes.
You have 1 minute.
So someone told me when you're looking at this big data, you don't look at it from qualitative or quantitative, just said structured or unstructured. And the fact is, when you're looking at, let's say, what you're calling qualitative, to a large extent it will be unstructured, maybe. So you don't need to worry. You need to worry that the subjective aspect of humans will affect the analysis process. And that's what exactly you're talking about. You should be able to include expert opinion, the analysis of.
You say it's unstructured.
So my teacher told me that don't look at it as quantitative or qualitative. Look at it from structured and unstructured data. So I was trying to explain that in what we call traditional analysis, we do qualitative analysis. One of the limitations of qualitative analysis is it's subjective. You use the information that you can't test. You can't do statistical tests to say, I'm proving this. So the fact that you're doing, it might be affected by subjective thoughts. Then what you need to do is a lot of research, include lots of domain knowledge, that you will not just use your understanding of the topic and your own perceptions and perhaps be affected by what you're calling confirmation bias and any other bias that exists. You need more than you understand. You need to be humble and let's say classify yourself that you don't know so much. You do lots of research on that subject so that the final outcome of the result, it's something that is reliable and valid, that I can replicate that in another context. It will not just be within this research and someone will be forced to do another research and get maybe their own subjective insights that are not related to mine. You should give some insight that can be replicated in another context. And that simply means lots and lots of research. I don't know if that was sufficient.
And I think now there comes a time when we need to have an oath for statisticians. The way they do for doctors.
The way the doctors do and lawyers. Because it's reached a level where AI and data scientists and data analysts they are becoming a very important part of our lives. They are, remember, designing models that can be used in improving our medicines, our
Even
health,
shaping our social lives.
healthcare, our social
Yeah,
life. We see
yeah.
what they are doing with our social platforms.
Yeah.
China and US are at loggerheads right now because of TikTok.
Yeah.
Because they're worried about how you guys going to collect
Exactly,
our
the politics and all that.
politics,
Yeah.
our security, our national
Yeah.
security.
Yeah.
So yeah, it's reaching a level where experts in AI, data analysts, data scientists, will need some what is it called? They need to
Some loyalty pledge.
So that if you go against the loyalty pledge, then you face some
You can be
consequences.
prosecuted.
Like
yeah.
at the level when we're saying we don't know,
Prosecuted, not persecuted.
yeah, or both.
Prosecuted.
At the
Yeah.
level we're saying we don't know what these closed AI, how it's being developed. We can only rely on goodwill
The human goodwill.
of those who are developing them, that they are doing it for the good of humanity.
Yeah.
But if someone comes and say, let me develop AI that will neutralize the whole of a specific race,
That
and
makes
we understand there are so many people who think like that. They think some races or groups are not important.
Yeah.
So they can use that AI for the wrong reason. So it's becoming a very important time when the developers or any practitioner in the AI sector need to do what is right.
Yeah, I like what you have just mentioned, and actually, when we have been touching about these mitigation measures, the issue of experts coming in, it's coming in handy. So that means experts play a very crucial role when these models are being developed. However, just maybe something, it's my concern. Something like, let me use a remote task as an example, because I know it develops these models and it trains these models that are giving people information. So, remote task.
Let us ask our technician if we still have
we still have some minutes.
Okay. Yeah.
Something like remote task, you'll find it's giving Amos questions to respond to, like maybe question in Swahili. Amos is not a perfectionist in Swahili. He even doesn't maybe understand some of the words in Swahili, but he responds to them, and that information is what is being used to test those models. How can that biasness then be solved in such area? And maybe Amos, to add on that, you can respond to that with also this question of, sometimes we handle data and we have missingness, and we say you can maybe do mean and maybe do what is this term?
Imputation.
Yeah,
imputation.
Impute with mean or mean impute. There are different methods of imputation, but do you think there are some of the perfect methods, and how can we mitigate on such?
Yeah. So our host, I don't know if we do have time. I'm worried that we don't have time. Yeah, but when it comes to labeling of data, and I think that's one of the biases that we talked about. Labeling can become an issue. Yeah, by these people who do the captioning, they can end up doing wrong captioning. Yeah, because when they're doing this work with this remote task, where they are being given tasks to train these models, they sort of act like agents who are trying to reward the system when it gives the right answer. Yeah, and the way we can reduce errors that can be brought in by these individuals is by having quality assurance team, which looks at what responses that they give. So what can be done is just train these individuals. I think they also do annotation, right?
Yeah,
they do annotation also. So you train them first, until they acquire the right skills. That's when now you can give this responsibility. And even after giving them the responsibility, make sure you do the quality assurance to make sure that whatever they did is as accurate as possible. That way we can train models which are accurately representing what is there in the society.
Yeah.
So that's one thing that we really need to do. So the other question, what was the other question? Imputation. So that one. First of all, when it comes to developing AI models, we don't have to worry about.
I don't want to worry about
Don't worry
it. You
about
don't miss your entry.
missingness. That one is a problem.
Should not be an issue.
It's not an issue for neural networks.
I think it's
or
an issue
AIs.
for traditional models.
And also it's an issue with small data sets.
Small data
If you're working in small data sets, it's a problem. Maybe if you have maybe 100 cases, or 1,000 cases, those are very few.
Yeah.
But now we're talking about billions,
Huge data.
huge data sets. So missingness is not an issue there.
It will not affect.
Yeah, but the issue that we can talk about is now the main. But I don't know if we can really solve that one. Yeah, because the mean from our statistical understanding, the mean is like the actual representation. In statistics, we have what we call the normal distribution, and most variables they do follow this normal distribution. So we know within let's say like 3 standard deviations from the mean, we have to have more than 99% of 95% or around 97% of individuals inside there. So it's about an issue of normality of the data sets.